Okay, my outstanding friends, I made a claim about a year ago about this, claiming that it could have been the blast of the white light, and from my experiments in dipole electron flood theory. And I also showed these things. This is also light from our experiments. Rod Warren did this from Australia. Fabulous work he did, and I can't discount this. Now, what I'm going to show you is my video from a year ago, which explains as much as I can explain. And it explains exactly what you see on here, all the details, like his side wound. I mean, everything. He was nailed through his wrist, and they claim that that's apparently they don't go through the hands, and that appears to be true. All these scourge marks all over his body. It must have been absolutely horrifying death. And from all the details in the scientific realm and my light research, I declared this authentic as being caused by a burst of intense radiation light, which is the white particle. And I show it, and I just did another video explaining what they are describing right now. This has been a year ago. I put it out. I said, you show me I'm wrong. Somebody tell me I'm wrong. And they did a big, long, very detailed study of this. I think it was after that, or they had been doing it, and I picked up on it. I can't remember. But now, they reached the same conclusion I reached. Okay, my friends, this is as serious as it gets. This is not a fake, not a forgery, and I will explain exactly what I mean. And they say, oh, it could be a painting. Well, no, and then they realize, no, it's not a painting. It says, if this was true, it should be possible to identify pigments used by the chemical analysis, just as conservators can do for paintings of old masters. They find out what kind of materials that they use to make these patterns. Now, the STURP team found no evidence of any pigments or dyes on the cloth in sufficient amounts to explain the image. They couldn't find anything. Nor are there any signs of it being rendered in brushstrokes. So they would have had to go dot, 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 dot everywhere to make these images if they were going to do that. It says, in fact, the image on the linen is barely visible to the naked eye and wasn't even identified at all until 1898, when it became apparent in the negative image of a photograph taken by Secondo Pia, an amateur Italian photographer. The faint coloration of the flax fibers. Now listen to this. This is extremely important that you understand this. The faint coloration of the flax fibers, which is the material they made this cloth out of, isn't caused by any darker substance being laid on top or infused into it. I'm going to read this again. It's not caused by any substance laid on top or infused into it, anything darker to make it look darker. It's the very material itself of the fibers that has darkened. What would darken the fibers? Singed, being singed. Literally the only way those fibers could be darkened is being singed. Why would they be singed in those exact spots? And why is there evidence of extreme singeing, like here, and here, and here, and other areas of a very diminutive singeing, where it's just changed a bit? Now, they say it's, well, let me just continue, hold on. All right, this is goes back to 2015. This is like 9 years ago. And how did the Shroud of Turin get its image? And at this point, Pope Francis is going to venerate the famous Shroud of Turin. Now, they say whatever, nobody knows how it got its image on there. Whatever it is, it's a mystery how the cloth came to bear the image of a man. Science writer Philip Ball discusses the theories. And there's all kinds of theories and guesses and so forth. It says there's no shortage of hypotheses. Some suggest the image came about through natural processes. Some impute considerable ingenuity to medieval forgers of relics. Others invoke wondrous physical processes associated with the resurrection, but do any have any merit? Well, I looked at all of them, and no, they don't. They don't. They absolutely don't. They can't find anything. Well, we're going to get into it, because I can tell you right now, as far as I'm concerned, that's as advertised. That was venerated as the Shroud of Turin, the burial cloth of Jesus Christ. And they didn't even know that it even had an image on it until they had invented photography and saw it as the negative. They didn't realize there was an image on there, as far as I know. And then all of a sudden it showed up when they could see it as an image on it. So we're going to go through the history, and they went into some deep detail on this. I was surprised they did as much as they did. And this goes back to, I think, 1978. Somewhere around there, 1978. Yeah, right there. It's studied in 1978, an international team of experts. And I looked through what they studied, and they did some detailed work on this. And they found that the actual fibers themselves were basically singed a little bit. And that's what created these patterns. Now, why would they get singed? And then they're trying to figure out who could singe them and how could they singe them. Could they drape a cloth over like a statue and then heat it up or something so that it would singe only in the areas that were touching? I mean, they did some pretty good work on this. But I can tell you what, I'm going with the fact that that was actually the emanation of the atomic bomb blast, just like I showed you. All right, so what else can we learn from this? We know Jesus Christ was crucified. It appears he was crucified through the wrists, this has always been in discussion. Was it through the palm of his hand? He would have ripped it right off. It appears they went right in between the bones of the wrist. That's what it looks like to me. Every single square inch of his body, his back, the back of his head, everywhere. The only place that isn't scourged is his face. And the crown of thorns looks like it was on his head, and it spiked into there and let some blood flow. And he has exactly the signs of the crucifixion, no question whatsoever. This was a guy that fits exactly the story. Now, this was burnt a little bit in a fire somewhere, and it burnt the edges of the folded cloth. Now, I'm trying to see if that might have some effect on this discoloration in these areas, and I say no. It did obviously cause quite a bit of damage in these folded areas. Now, would that have affected the fabric where it might have touched the skin and had some oils and so forth on it? I tend to doubt it. I see this as when they say that there is the fabric itself has changed and become darkened. And when I see the darkened spots, are different in different areas, and especially where there's actually blood flowing. This is a little bit tricky, but I'm going to go with the fact that this was an actual factual relic that was saved and preserved because it was the real thing. And you can't dispute now what I'm showing you. Certainly, absolutely, 100% shows that it was a crucified guy, human being, or Jesus. I mean, I would have to go with Jesus. That was the story. They preserved it. They saved it. They elevated this to some status of, really important historical, item. I got to go as real. I'm going real. Everything you read about in the ancient text is about you have to return to the pure light. Watch this. I'm going to slow this down to where it's 25%. Because this is the atomic bomb blast. Now watch what's going to happen. They got a truck out here. They're delivering all the equipment. They're setting it up. They've got look at this. Now watch the white. What do you see? The white came first. That's Jesus's spirit, his soul, his white light getting pulled away from the darkness in his body. And the white light is singeing the fibers as it goes out back to heaven. And now after it singes all the way, watch. Singe, 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 because it is removing the white particles from the black, sending them back to heaven. And now the black comes after it, chasing after it, and smashes the house down. Watch, this is just all singed. Boom, here comes the black part. And everything you read about in the ancient text is darkness and light. And the light is escaping from the darkness, and Jesus' body split. And the light went through the fibers, converted them into dark, basically semi-charred fibers. And the more substance, which is blood, has all the metals, it will be the more change in that fiber. All right, all they ever talk about is about the brilliant light, and you come from the light, you will return to the light. There's a stream of light which we are come from, and we will return to it. These are what they say. Now, this is the Gnostic text. This is the Gospel of Thomas, and supposedly this is the words coming right out of Jesus' mouth as he walked the face of the earth. Jesus said, "If they say to you, 'Where did you come from?' say to them, 'We came from the light,' the place where the light came into being on its own accord and established itself and became manifest through their image. If they say to you, 'Is it you?' say, 'We are its children. We are the elect of the living Father.' If they ask, 'What is the sign of your Father in you?' say to them, 'It is movement and repose.'" Light can be very energetic, and it can just be sitting around as nothing, basically just matter, as heat. That's movement and repose. Where did we come from? The light. Well, the only place I know where the light comes on its own accord is from the sun or luminous bodies like stars and so forth. It came into being on its own accord. It just, light is just spewing out of there. It's because we're rubbing through the universe and scrubbing all that heat out. And we are its children. We are the children of the light. And this, the Shroud of Turin, as far as I'm concerned, is a product of the light coming out through there. That's the only thing I can conclude after seeing that there was no residue, no dyes, no this, no that. It was a discoloration of the actual fibers. And this stuff here is not red ochre and just nothing, red oxides. It's blood. And so they really dismiss everything in academia, and they just throw these words, "Oh, that's just red ochre, that's just iron oxides." Well, what do you think blood is made out of? It's made out of almost 100% iron. Okay, my allegation is going to be that this is the bright, burny stuff that shoots out and had created these patterns based on actually singeing the fabric. The dark matter is the weight of everything. The dark matter is what you want to separate away from. The dark matter is your physical body, literally. The white part has no weight whatsoever. It has no weight whatsoever. This part here is all energy. It's all energy. It's all of our energy. And when that goes, the black part has nothing. There's no weight. All it is the matter, and that's the disposable part. We want to get away from our matter bodies into this part, and this is what Jesus did. Gone, and then the rest was just matter, which is you don't need that once you go into the heavenly realm. And that's what caused the burning of this. And I intend to show this in actual material way. And I'll show you how light, when it shoots out in an atomic bomb, and that's what literally Jesus' body did. It separated the white from the dark particles. The dark particles are mass and matter. The bright particles are energy. They have no weight whatsoever, but they're the same thing as electricity. You charge a battery, it takes on no weight whatsoever and has all kinds of energy. The rest of it is just dark matter. And that's what this is right here in the center of everything. I'll explain it, I hope well. And if it's not well, I want you to talk to me about it and tell me why you don't like it. Okay, my friends, this is going to be exciting. This is about a solar eclipse that happened April 8th. And this is Michael Padilla. He's from the Lawrence Livermore Laboratories, National Laboratories, and they are going to be discussing what they have discovered on the solar corona. Now, the solar disk itself has a certain temperature, but way out on the corona, it's extremely hot, and this is just not understood. Here's what they're saying right now. Okay, understanding the solar corona becomes crucial as the number of satellites in space increases. Flares and solar wind material ejected from the sun's atmosphere affect space weather, which can interfere with satellites and GPS, and it could cause problems here on Earth. There's also a long-standing fundamental physics problem, coronal heating. All right, well, what's the problem with coronal heating? Remember this, there's also a long-standing, fundamental, that means the most basic, physics problem. Coronal heating. Well, what's going on? The sun's, and this is in quotations, the sun's corona is actually much hotter than its surface, which is a bit counterintuitive, which means they don't know or have a clue why it does this, said Fairchild. This is like if a light bulb raised the temperature of the surrounding air to a temperature much hotter than the light bulb itself. We don't completely understand the solar atmosphere at higher elevations where we had expected it to be cooler. But it is hotter. All right, he says, if you're interested in this kind of work, Lawrence Livermore is one of the best places to be, said Fairchild. Well, I can tell you precisely why it's much hotter out at the corona, and it's because of scrubbing. It's worse than I thought. Since the 1980s, the researchers at Lawrence Livermore National Laboratory, which we're paying for, have been unraveling the patterns in the solar corona using a device called electron beam ion trap. Well, I don't know what that means, but we used a cell phone and worked pretty damn good. That's the problem. If you know, funding drives everything. Unfortunately, I don't mean to be bitter about the whole thing, but you know, when they won't pay attention to something that could save us a ton of money and be something that might help save the planet, because it is, I know it's going to affect their funding and so forth. Yes, it probably will, but there's so much possibilities going on here, so much to learn. They should be able to transfer it right over, but we should get something for our money, not just be wasting the money walking around in circles. If we could get something like this, just think of the benefit of something like that. I'm going to leave it at that, because I don't know what else I can say. Things have to change. I got books, and I've got papers, and I got all kinds of documentation, information, and experiments and so forth to show this is pretty valid stuff. And the electron flood theory, just look it up, dipole electron flood theory, dipoleelectronfloodtheory.com. And it just explains it. Very, very simple. You know, even like a 16-year-old kid easily can understand this. And these are the only two particles that exist. And when they're in the process of forming photons, they're in what they call a neutrino phase. They have different colors. And then they turn into gluons and then photons. Gluons are electricity. Photons are the things that bounce back at you. And these are the things that are going to change. Space, there's a lot of changes in space because light slows down. All this web stuff, that's nice. It looks wonderful, but it doesn't tell us where we are. Redshift, total nonsense. Space-time distance is meaningless. Chemistry, that I got a lot to learn about because the periodic table changes very little. However, the isotopes are the things that we really want to focus on because they don't understand isotopes. I don't want to get too deep into that now again, but this is something you want to look into. Just to look, it's like a 2-minute read. Now, there's this possibility, and I think this is the one. That's the one I'm going with now. But I also thought of this one here too, which would have layers. In between each layer of glowy particles, there'd be another layer of dark particles, and then another layer of glowy. But there'd always, the outside would be the glowy particles. So if it's a small atom, there's only going to be blue around here. Like hydrogen's just going to have the blue, and that's why it's so explosive. Whoa, because that blue is tight. When you put a spark in there, off it goes. Now the green is not quite so tight, and the red is kind of loose. Is there a black thing in between? I don't know. I think all the black squishes right to the center. I think that's what I'm going to go with. My friend Oscar Rosales did this, and he is doing absolutely fabulous, wonderful, nice work helping me to make this understood. And it really is not complicated. It's not complicated at all. All right, and like I say, there'll be more to come on this, all right? So, I guess we'll have to leave it for that for today. But the dark matter is right there, and that's gravity. Gravity means we want to pull all the white stuff in, and everything there is has white stuff attached to it. So everything is pulled to the Earth because the Earth is literally dark matter. It's a sink. It's ground. Every electron wants to get to the ground, and everything there is has electrons saturated with it. So they will want to get to ground. That's what gravity is. That's all it is. All right, thank you. Okay, space cadets, let's go out to outer space, to the Russian space station, and watch this reaction that they filmed close to 10 years ago. And they injected charged particles into a vacuum chamber in space, and this was what happened. As these things bounced around, they formed a black hole in space. We're going to get into this in a second. But as they congealed and flopped around and did all of the normal things that happen in space, these charged particles began to congeal in such a manner as to form a black hole in the center of the this is what happened. It kept jiggling, forcing more and more black. They couldn't believe it. One guy locked himself in his office for several weeks. Okay, you better get boned up on this and start to understand black holes and supermassive dark matter and all that stuff. Listen to this. They're saying dark matter could provide supermassive black holes the brakes they need to bring them crashing together and a spiraling journey towards their destiny. Well, what does that mean about dark matter? How would it do that? Well, guess what? There's only one problem. Now, the only problem is with dark matter is we don't know what it is. I have no idea what it is, but it absolutely could solve this problem. We don't know what it is, though. We call it dark matter just because they don't know what it is. It's dark. And then they made some big simulation of a program to things interact to show that they could fuse dark matter black holes together and make supermassive black holes. Well, I'm going to show you actual black holes made. You don't have to make them supermassive. You can make them super tiny. There's one right there. And we're going to go through all this very deep detail. Okay, we're going to get deep into dark matter, and there it is right there. They call it a muon. They don't realize it is the dark matter. And this is from our experiments. This is from Fermilab and CERN. They can see these particles, and they call them Dirac neutrinos. When they're split, it's a muon neutrino, electron neutrino. Same thing we have here. Muon neutrino, electron neutrino. Back to back, two of them make a photon. They smash them and they just see them in particles. So they don't really see the photons like we see them. These are strictly photons coming out of a laser. Now, this is the muon neutrino, the black ball, and this is the white shower, electron neutrino. And that's what we did here. And we separated them. The black ball was separated from the white in the Venturi. So I am claiming this is dark matter, all right, and this is the glowy part of the energy part, and I think I'm going to get pretty deep into this in a second, so stick with me on this. Now, that is, my claim is the dark matter, and I show this in a multitude of ways, and the dark matter literally is the mass, and it pushes the white matter, and this is coming through the Venturi. This is a real slamming waves, and this is what they call the Whistler waves out in front of the white particles. It's literally identical to an atomic bomb blast, no difference whatsoever. I'm going to show you the gravity waves in space. All right, these are out in space. I'm going to show all of these things in great detail, but the whole thing is the dark matter is really almost the only thing that has any weight. And they say it's 85% of the universe. Well, what's all the weight of what I have here? This dark matter is in there. It's because dark matter is attached to everything that is glowy. And the glowy part always surrounds the dark matter. The dark matter goes to the center. It's like this. All of these particles are charged bouncy particles. When they come and they hit something, they bounce back at you. When you shine light on it, it bounces back at you, but you don't realize way in the center is what has attracted all that white particles onto that dark matter which sits in the center. Now, you can't get that apart from the center unless you split this in an atom smasher, or you put it through the Venturi like we did. They do not come apart. Those two particles, that's the strong nuclear force. You see this right here? They will not come apart. Those two, they don't want to come apart. When you have to tear them apart, which is exactly what we did in the Venturi. All right, and the Venturi does this. When you bring the particle through, let's see, there's the wave. It's a particle coming through the rest of the air, basically, that's all it is. And it's got a field around it like this, but the particle is just almost nothing. Here it's accelerating to a point where it's actually pulled the particle out of the magnetic field, and here it explodes at the Venturi, and literally explodes. And coming out the other side of the Venturi are these Higgs fields coming at us. And that's the particle that is squeaked through there. And here's what it looks like when you get real close up to it. It comes out with the neutrinos, which are not quite photons. They're these type of things here in this. This is a full-fledged photon. And they come green, they come red, they come blue. There's the green ones. And all it is a faster spin, which gives it more energy. And the blue is the highest energy, and you can't even hardly see that. It's spinning so fast that here you can't even tell it's two particles. Up here you can just barely see. So the blue you can't really work with. The red and the green, red you can work with. The green, a little tough to work with. And these are the Higgs fields coming at us. So I'm saying right now, everything that you look at has dark matter in it. Everything has dark matter. And inside of you, we all have dark matter in us. Every electron, here it is right here. Every single electron, which these are dipoles, here's what they look like. There's a black and a white one tied together. All right, that's what and really, in the world we always thought of, that would be an electron. Nobody knew the black one was here. They thought the black one was all one big ball of proton. Well, it's not really. It is in a way, but not really, because they only had a few little electrons around it. Like hydrogen, they would have one big ball like this, and they call it proton, positive, all positive, and one little bitty thing out here, which is a negative. And that's just not how it is. It's 1,823 particles that are, or each one of them is a dipole altogether, and they're little ball dipoles. They're magnets. That's nothing more than a magnet. But they're round, they're balls. And they could form little balls like what I'm showing you up above here. Right, like this. But the black goes to the center and the whites surround it. They can separate down at this level. Once you get up to atoms and bigger, if you break it in half, you don't get one positive and one negative. You get two new bar magnets. But once you get down in the range where we are, where you're down in the atomic range, the subatomic range, then you can separate them. And I show that extremely clearly. There is no question whatsoever these are being separated. This particle is coming through here. Hold on. Where was I? Hold on one second. All right, so let's just get into the videos, but it's all about this stuff. Light is literally dark energy and dark matter on its way from the sun to hitting us. Until light hits something, it's literally almost all dark matter. The white part doesn't have any glow to it because it's not interacting with anything. When it does interact, and it does, coming through space, they say it interacts like, well, here, hold on a second. This is Fermilab, and they're showing these two particles. And they say these two particles make up the quantum foam, which is out here. It says empty space isn't empty. All right, those particles are out in the vacuum. Well, there's no vacuum. They're out in space. It says the empty space experiences the similar activity of the bubbles appearing and disappearing on the head of a root beer. These subatomic particles, the ones I'm talking about, winking in and out of existence. That's because they're getting hit with other ones. These particles, subatomic particles, are real and have a measurable impact on our universe. Empty space isn't empty. Once again, this is Fermilab. And they're right, empty space is not empty. It's saturated with particles of light and dust and every other kind of debris that's out there. That's why particles coming to us, they have to go through all of that stuff. Look at this. They have to come through all of these fields and dust particles and everything else that are out in space. They don't just come and never slow down. They're coming through all kinds of things. And look at the fields. Every one of those fields has to interact with another field, which means it's going to slow the light down. No question about that whatsoever. So when they say we're 500 billion light years away from somewhere else, they have no idea. Was it going through dense space? Was it going through sort of empty-ish space? Was it, what happened to that light on its way? It didn't just go zip and it just never slowed down. We know for a fact we can speed it up. We can slow it down. Here it is slowing down. And here it is speeding up. Okay. And this is just in the air. This isn't even in a vacuum or anything. And it's speeding up. That's not supposed to happen. None of this is supposed to happen. And light is a particle. There's no question about it. That's light from a red pulse laser. There's zero question about it. And it's the same particles, identical, with the glowy edge around the black one and a fuzzy one that can get big and small and has no mass. And this is what you put in a battery when you charge your battery up. And it has no mass. When you add that white stuff into a battery, the battery gets very, very powerful. It does not change in the weight. It doesn't add any weight to it, but it gets extremely powerful, and you can just keep adding more and more of that, and you're never going to change the weight. It has no mass. I can't account for that. But even Fermilab says the same thing, right here. These are the particles. All right, here's the one with the glowy edge around it. Here's the one that gets big and small and squishes down and has all the energy but no mass. So here's the summary. All right, we'll get right down to the bottom line. He says that black particles have a fixed size, just a fixed size. They never change size. They're like a bowling ball. You can't crush them. You can't do anything when they're a fixed size. That to me is the dark matter. It's called the muon. So then they call it the extended particle, the muon, the dark particle. It has a fixed size. That's this one right here. Never, ever, ever, ever changes. If you look at it in a magnifying glass, it gets bigger. See? If you look at it, it just gets bigger. But if you look at the point-like particle, it doesn't change in size, but the more close you look at it, the stronger the field surrounding it becomes. That's because you're putting more energy into it, and the field bounces back at you. It's just not because your eyes are looking at it harder. Now, the fixed size is the black one. It has a fuzzy edge around it. Yes, it does, as I have shown. It has the color of the particle surrounding it. The point-like particles are mathematical abstractions, zero size, and I have to agree, they have no weight. I don't know if that means they have a zero size. They have a field, and they even say that. It says even the zero have an extended field surrounding them. So I have to agree that, and there's no question these are the two particles. Absolutely zero question. That's the one they found. These are the ones we found. But we found them attached to light. So they never get big one like this and smashing. They smash things like this together. And then they get all kinds of debris coming out. And they dig through it. And they do find these particles. But they don't know where they came from. We know where they came from because we started with light. We started with something that was like 1,000 times smaller than what they started with, because they started with protons. Here's what they end up getting. Proton, neutron. They're actually hitting two of these together. Boom. And they're getting blobs of this and blobs of that and little pieces of this and little pieces of that and all kinds of things. They call it a particle zoo. We didn't start with that. We started with this. We started with that exactly right like that. Two bar magnets back together, little tiny dipoles. And when we hit them, we could see the little bitty parts, yes. And we could also see the black parts, yes. But we didn't have to dig through all the debris. And that's what they're digging through, is debris and making all of that exotic measurements and smashing things. They should have started with the small particles like we started with in the beginning. They got down to here, but we started with there. And then we split them. That's the key. We did way ahead of that. There's the black with the glowy edge. And the tight atomic attraction. And here they are, broken apart. The sterile muon and the electron neutrino turns into electron showers. So this is a pretty big deal. So let's continue on. But all this is about dark matter and dark energy and about black holes in space. And the Russians actually created one. I'm going to show you all this stuff. So let's get started. Okay, I have to prep you for some of this stuff, but eventually we're going to get into the black holes in space and to what the Russians did in space. And I paid attention to this back then, and I communicated to the Russians about this, about what they found in space. And they, I don't think they realized what they did find. And these are the actual particles and what they're looking at and how they're responding in weightlessness and the actual physical particles. And look at this. Now, this is what really got me, this is the plasma experiments. And they're actually injecting energy in there. And I don't think they realize what they're doing. When they're focusing in on there, they're putting energy in. Now, this is where it really gets cool. Look at this. You see what's going on here? These are charged particles, and they're making literally the formation basically of a galaxy and a black hole eventually. And eventually they do come out to somewhere around out here. I go through this whole thing in great detail, so don't worry. But somewhere, well, actually they come up with DNA too. This just spontaneously formed. I'm not saying it's DNA, but it has that double helix look. And they actually came out with the black hole. And I think I showed you that. Yeah, right up here somewhere. Right there. And it all bounced like this, and then they settled in and made a coating. And so anyway, we're going to get into this deep. Let's just get into some discussion about it. But stick around. This is going to take a while, but I'm going to show you the nature of dark matter. Because dark matter makes virtually almost 100% of the weight of everything. And everything here has weight. It all incorporates dark matter into it. They just never realize it. The dark matter is inside, and anytime you shine light on it, it does not radiate. You never see it. This, though, you can see because this is outer space. And this is in a vacuum chamber in not quite zero gravity. See, it's sort of flat. If this was zero gravity and there was no pulling to the Earth, it would be perfectly round. But it's still sort of... Anyway, you're going to hear the whole story momentarily. Okay, my friends, one of my favorite topics, dark matter. This is a shocker du dark. Now listen to this. Now, the problem with dark matter is we don't know what it is. Now, it doesn't interact with the normal matter of the universe beyond its gravitational pull. They know it sucks everything together, but they don't know why. It makes it extremely difficult to probe. We call it dark matter as a placeholder term, really, and scientists are trying to figure out its properties by studying the behavior of the universe in other ways. What they did was they made some gigantic computer program to show them what black holes are. I don't think you can make a computer program to do that. I just don't think it's, you know, what they're showing here I don't agree with completely. They got some, you see that? That's supposedly gravity waves out in space. This is their little drawing, the little doodle they drew. Well, here's the real thing that's happening in space. This is taken strictly with a cell phone. Some kind of app, I don't know. I got it from a guy in Australia, Dylan Carpenter. He just sent me these pictures. I never heard another word from him, and I try to contact him. I can't get through. I don't know exactly how he did it, what kind of a thing but it was a new cell phone. This is 3-4 years ago. And he took these pictures. Now, that's the moon, and I understand why the blue is here. Do you? Now, I understand the dipole nature of these particles, and I understand these fields that are around them, and I understand that when light comes through these fields, it slows down. Light does not keep the same speed through the universe. And look at this. It's just a gigantic mess of things and fields that overlap and intertwine, and they do all kinds of crazy things. Now, what is dark matter? It's right there. That's it. These are the Russians in space. During the experiment, we contacted the Earth guys who couldn't believe it either. They saw this and they went, whoa. And I know why. I know exactly what happened here, pretty much, I think. I'm going to explain it to you. There's a video they show of this whole interaction, how all these particles interact with each other. And I contacted the Russians about this when they actually put this video out. I think it was close to 10 years ago. And I also contacted a Fermi lab too, because I could understand the bright and the dark particles, because I could see them. Fermi lab was seeing them. CERN was seeing them, and I'll tell you how it all ended up. Okay, see this goes back to 2013. Don Lincoln at Fermi lab put out this, and I saw this. I think it was probably maybe 2015 or so. And I say, these are the same particles we found. And I could understand when I saw the Russians video why they separate the way they separate. And they can only separate that way in space. They can't separate that way here on Earth. which gives you a black hole in space. You can't create a black hole on Earth. There literally is, I believe, in the center of the Earth, a black hole. I believe that's true. And it is absorbing all of the white particles towards it, because they slam into the Earth. There's nothing more than they want for these to get to the dark matter. That's the strong subatomic nuclear force. So when light comes down as bright, brilliant particles of light and electricity and lightning and static, it's this particle right here. And what does it want to do? It wants to get to that particle right there. Well, where are those? That's where the Earth is. Lightning, static, electricity. It wants to get to ground. That's literally ground. That dark matter turns into a ball on itself. It doesn't care about being on top of itself. The white matter does not. The white matter pushes everything away and creates a high energy. The dark matter is strictly gravity. And in that case, they are correct. And the other thing they're correct about is the Earth is not, the space is not empty. Empty space isn't empty. It's like a saturated foam ball out there, and there's particles going through it. Slow down. There's just no question whatsoever about that. All right, there is something here that they're not taking into account, is when they are taking pictures of this, they're shining light into it. They're illuminating this. Light is not nothing. Light is charged particles. They are actually charging up this plasma, and then it just discharges. Watch what happens. And I don't think they understand this. You see, it like rises, and then all of a sudden, this is a plasma crystals. And then all of a sudden, it'll just collapse. And I think it's absorbing more and more energy, and then it just drops. And now it starts to absorb, and then it drops again. And it appears that plasma isn't really a fluid, it's a crystalline lattice-like structure. Then they're showing this. Now, you see these particles spinning around here like crazy, and then all of this. These are 4 different shots, and I'm sure they're all the same picture. Now, I really couldn't get to talk with the Russians about this, but they're all at the exact same time. And I think they're different types of cameras, picking up different types of particles. So there's 4 of them going on. Now remember, we saw this one. This is the big one. Now when we get down into here, I'm going to run this real slow so we can watch these speeds. Let me come back here a little bit. All right, so here we go. Look at what's going on around here. They're coming around this edge and coming up. And they're coming around this edge, and they're just going around in a circle. You see this? You see that? That's the polarity in between the dipoles. This is very, very interesting to look at this in its extreme details. So you have a dipole, one on each end. Now this is happening at the same time. You see that stuff fall down, and now it's going to come back up again. What's going on? This is going to take a lot of work to try to understand this. But these are apparently the charged particles, and they're working themselves around here. And there's the cap is up here, and down here is where the action's occurring. Now there's an interaction spinning particles here, spinning these particles here. And they say the dust particles are suspended within the plasma. So the particles are charged, and they experience repulsion from each other. The charged particles, whenever they're charged, they repel. And anyone that glows repels. They get an electric charge and experience repulsion. So the glowy ones push each other away. However, the thing that they don't understand is the glowy particles are extremely attracted to the dark matter. So they congeal around the dark matter. So let me come to the dark matter. Now this is like the stagnant particles in the air. Now, what they're going to have is, because of the repulsion, which is the white particles pushing the other ones away, they line up and they create a crystal lattice type structure. Now watch what happens. You see, these are, I don't know, I'm not sure what's going on here, but I know the white ones are pushing each other away. See, they're bouncing into each other and they're pushing each other away. So they saw that and they were kind of interested in that. And then they're showing how these particles come in, all in a stream. Hold on, let me back that up one little bit. Let me just sort of drag you through this. Hold on. Okay, the plasma that they're making is these charged particles, and they're creating it in this black bucket chamber. Now, I know they're looking into there and they're shining light on it to illuminate it, I think. And this is what I would love to have been able to correspond with them, but it didn't work out that well. Now, but I did try. Now, so this chamber, micron-sized dust particles are then allowed in. Micron means just the tiniest little bits. You see them coming in like this, and as they end up hitting, they're going to all swirl around and all that stuff is going to happen. But see them coming in basically in a line, almost like a stream of particles, one right after the other. Now, are they somehow glued together like these kind of things? Coming in with dark particle between? I believe they are. If you look at it carefully, I believe that's exactly the case. You see how they're separated out just a certain distance? I believe that's what they are. You got charged particles and you got uncharged particles between them, which is the dark matter. And they're pulling each other back together. The dark always pulls the white in. And the dark will lay right on top of itself. It couldn't care less about being on top of itself. The white hates the other white. So when it came in here and it started, working its way around here, the whites are bouncing off all the other whites. All right, so they're just sort of drifting around, but they won't get real close to each other. When they do, they just push each other. They get bright as they get close. You see, watch them when they get close to each other. They brighten up. See them? Boom, boom, boom. They hate each other. When they do, they just get bright, and then they push each other away. However, they are overcome by attraction of the dark matter, and that's what ends up happening. Now, this is what freaked them out. They were expecting to see nice clean lattices like I showed you before, where the particles are sort of sitting in their own, pushing each other away and staying away from each other. However, this happened. Instead of a clean lattice, there was an empty void appeared in the middle. So let's look at that empty void, and you watch it. It's gonna bounce up and down like this. So he's showing what it's going to be like, and all those particles are trying to get to the dark. So they're bouncing back, bouncing back, bouncing back. Watch, you see, they're all floating around, and then all of a sudden the black shows up in the middle. Then they freaked out. They said during the experiment we contacted the Earth guys who couldn't believe it either. I said, why did that show up? Let's look at it back again, because this is just stunning to be able to see this in real time. All right, and again, I got it running real slow. So he's saying this hole showed up in the middle, but before that happened, they're just all bouncing around in here. Now, they're all trying to stay away from each other, and they end up pushing all the black in the middle. And don't forget now, my claim is the black could not care less about being on top of itself. There's all kinds of black particles in here. Every one of the white should have a counterpart of a black. But the white can separate from the black, and the black is all being pushed in here. That cannot happen on Earth, because it would be flat like this. All the white particles would be pushed onto the Earth's surface, because the Earth is this black hole. Basically, in outer space, there is no Earth. It's trying to come down a little bit. You see how it's sort of flattened out? If it was way out in the middle of nowhere land where nobody pulled on it, like, is it being pulled on by the Earth? It's still being pulled on. So it's sort of flat-ish. Now, if it was way out in the middle of nowhere land, it would be perfectly round. and it would be surrounded by white particles, which is what they see as the black holes in space. Now, don't forget, everything that we have has a weight to it. Everything has a weight to it. The white particles have no weight. The dark particles are inside of every single atom and every single particle. Light is made half dark matter and half white matter. This stuff the Russians did in space was amazing. This is like a DNA strand that started to just form all by itself in this same chamber. Now, I have some questions myself. This is what they found, and again, they couldn't believe it. One guy freaked out, locked himself in his office for 3 weeks because he just couldn't figure out, and they still can't figure out what happened. I know exactly what happened, basically. I believe I do, because I can see that we could separate the white from the black. All right, and on Earth, again, you cannot do this. They are going to be stuck together. The black and the whites are going to be stuck together. But if you could separate them, what would they do coming back together? I think they'd come back together as a black hole. So what we did was we could separate them. We shot them through a Venturi. And the black stayed on this side, the white separated. So we know we have a separation of these two powers. There's no question. These two were locked together here originally as light. We ripped them apart through the Venturi. Coming through the Venturi, they ripped the white from the black. And we ended up with this. The black could not get through with the white. So the white now is separated from the black. If this was in space, what would happen when they came back together? Would they come back together as just light, or would they come back together as that black hole in the center and surrounded by the white? That I'm not sure. I'm not sure whether they would, because here on Earth they come back together, and this is fission. All right, just think about this. Just think about it. Coming through here, the black and white was tied together. Here they are, right there. This is every single particle of light is made just exactly like that. Green, blue, red, doesn't matter. And the black is attached to the white. And they have found this at CERN and Fermilab. The same two particles attached together the same way. This has no weight whatsoever, has all the energy. And that's what you put in your car. When you charge your car up, it weighs 4,000 pounds. When you drive 500 miles, it still weighs 4,000 pounds. When you charge it back up again, it still weighs 4,000 pounds. This has no weight. All the weight we experience and everything that we have here is made from dark particles. And the dark particles are inside the white particles, so we have never seen them before. All we ever see is the white glowy particles. But deep inside the middle of that is going to be your dark matter. And it's just going to congeal into a ball just like that, because they don't care about being on top of each other. The white different. You saw those surround the black. This is what you just saw out in outer space, is that. The black's in the center, the whites are just going, vroom, 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 trying to get a hold of this. And that's their whole mission in life, is to get back to that black. So once we separate them, they said, whoa, 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 we're not going to do this. We're coming back to you white guys. All right, and somehow the black is got to be laying over there just waiting to attach, because I don't think they jumped ahead to get back to the white. But they do attach right back together, and you end up with Higgs fields over here, which is these showers of particles coming away. And we have seen all of these things in our experiments. Very, very similar to what the Russians were seeing in space. All right, so don't forget, these are charged particles. They added extra electrons to them. That's why they're glowing. But I think they're glowing because they're shining a light into this, illuminating it by bouncing it back at them. I don't think they're just glowing all by themselves for no reason. And this would also account for the dark center, because dark matter does not reflect, so it wouldn't reflect back at us. It doesn't emit, and it doesn't absorb. It just is there. So you shine the light on it, you're not going to see anything come back. This is where the dark matter is. When we shine light on white matter, on bright stuff, it bounces back at us. But dark matter doesn't do that. So that really pretty much accounts for what we're seeing here. And this crust will just kept bouncing. Well, hold on a second. You see it bounce. and it's trying to pull more and more white down around it, and it just keeps bouncing and bouncing and bouncing. You can see the white is collecting more and more around here. Isn't that something? And that is literally a black hole. It says one of the scientists from the Max Planck Institute saw this and freaked out. He locked himself in his office for 3 weeks. You look at that, you say, well, how could that happen? He found receiving the data, he locked himself in his office for several weeks. All right, you see this? Remember I tell you, on Earth, you can't do that. On Earth, it's going to crush these. On Earth, the gravity squeezes the crystals flat. Let me set it back up so we get regular speed. All right, so on Earth, the crystals, see, they come down like this. Up there, the black particles went into the center and pushed the white particles apart. It's impossible to study this stuff on Earth, so you have to go into space to study it, where it can sort itself out into basically the atmosphere that's out there. Now the vortices resemble a galaxy spinning. All of these particles spinning, and all this stuff is happening. Look at this. It's very, very similar. Now, why are we seeing? Hold on. Whoops. Let me open this up. Why are we seeing these particles in these formations? You see that? They're letting them come in, and they're just sort of spinning around. Don't forget, the white ones hate each other, so they set up these patterns with dark in between the whites. That's the whole idea of the spinning galaxies. They don't want to mix together with each other, so they push each other in the center. This is what's causes the Higgs fields. Let me show you the Higgs fields. All right, this is basically slow motion of what we did with the light going through the Venturi. This is just the charged particles interacting with each other, forming these circular fields. So as they're saying, it's a mini galaxy. Well, it's also a mini Higgs field. All right, you see what they're doing? Let me show you the Higgs fields. All right, these are from the experiments we did with red pulse laser before it accelerates. It's just beginning to accelerate. Then full acceleration mode, and it exploded here. The particles were these black and white particles together, which is the photons. The black is the dark matter. That has all the weight. So light is half of light is dark matter. All right, so it's coming through here, and it explodes at the Venturi. Coming out of there is these Higgs fields. You see these circular pattern fields? Do you remember what I just showed you here? These circular pattern fields. It's the same thing, only it's much faster because we're working with light. But they're the same charged particles pushing each other away to form these spinning fields as they come forward. See, these are the Higgs fields coming right at us. All this was done with this Samsung phone, Samsung Galaxy S3, and a cheap pulsed red laser, construction laser, caused this. Now this is something unusual. This is pinched fields turning it up to blue from red. Blue is very powerful compared to red, but this started out as red. That's kind of unusual. We got some real unusual stuff. Rod Warren did these and did just a fabulous job. You know, I did a little bit, but nothing like him. I must have spent thousands and thousands of hours. And these are the photons. And the dark matter is part of the photons. It's both. It's the dark matter attached to the white matter. And they come in as these neutrinos here, and they change values until they turn into photons, and then they exploded and did fission and fusion at the Venturi right here. All right, they broke apart here, and they came back together here. That's fission. When something breaks apart, it's fission. When it comes back together, it fuses together, fusion. Here you had raw white energy. And I don't see why, if we could harvest that energy right there before it got back to the black, that's all you want. It has no weight whatsoever, and all the energy to do all the work. No weight whatsoever. All right, so don't forget, everything is made of light. There is nothing that isn't made of these two particles, the black and the white ones. That's 100% of everything. Here they are automatically in space. It looks to me like they're turning into a DNA type strand. That sure looks like the double helix to me. I don't know what you see there, but that's what I see. And that's spontaneous by itself. Is DNA just created in space? Could it just assemble by itself and turn into some wacko crazy thing? Or is it always assemble in the same way? I don't know. Is that even DNA? I have no idea. But I can tell you what, that was on the Russian space station. This was on the Russian space station. I don't care what anybody said. That is right there is dark matter. And that is all the white particles are pushing it together. The black could not care less about being on top of itself. The white will never stay on top of itself. It will always push the other whites away. White always pushes other whites away and desperately seeks the black. The black just lays there waiting for the white to come. And when you have the white separated, one ball of white here, all right, when you have the white separated, all right, so if you could just get that ball of white and put the black anywhere, I don't care where it is, and you run a wire from that white to the black, that's electricity. That right there is electricity. It has no weight whatsoever and unbelievable amounts of energy, as you can see. That is a subatomic nuclear explosion. Subatomic means it's smaller than an atom. It's light, which is the smallest you got, basically. It exploded, though, so it's a subatomic explosion. And then it came back together, fission and fusion. And this is the product of a light particle explosion. We're not talking about a big atomic bomb. We're talking about light. That's pretty impressive. And when you create increased illumination, you have increased energy. So whatever this was here, I don't know how much energy. Whatever it is there, it's increased. That, my friends, is a fact. All right, I mean, it's just very, very obvious. Luminosity, yes, I asked, is luminosity increased energy? Yes, increased luminosity is increased energy. So we brought it from one energy level up just by putting it through the Venturi. We didn't have to do anything to it. Luminosity is the amount of energy emitted. That's all you got to take away from that. That's the amount of energy emitted. So we created from almost no luminosity whatsoever. Back here, you couldn't even tell the particle was there. It starts to accelerate, and then it becomes very visible, and then it exploded. That is extreme amounts of luminosity. And that is the white energy completely separated from the black energy. Exactly what happens when you charge batteries. You remove the white from the black and force it into a battery that accepts it, but the battery never changes weight. No change in weight whatsoever. You force that white into it, no weight. I can't explain that. I really can't. I can't explain it. But boy, I'll tell you, that white has a hell of a lot of energy. And then when it flows through the wiring or wherever it goes to the black side, boom, you get a lot of work. It drives motors, it burns things, it heats up plates, it lights up lights, and it will go right through your body and burn you. Depends on how much energy there is. But when you have lightning and static and so forth, it wants to get to ground. If you're in between the lightning and the ground, you're in trouble. It'll go right through the water molecules in your body until it gets to ground. And in that meantime, those water molecules explode like a bomb inside your body and literally explode you. Okay, I think we can leave it at this for today, but this is the new atomic model, is the dipole electron flood theory, and there's an equal number of dipole electrons in every nucleus, and the nucleuses of atoms are made out of stable quantities, and the first stable quantity is, I believe, about 1823 of these dipoles. And I based that on the fact that Millikan's oil drop experiment said that each electron weight So the weight of each electron, which is a black and a white one together, weighs 0.005845 atomic mass units. That means if you multiplied that times 1823, it would equal 1. All right, so 1 proton has 1823 or so, somewhere in that area, of these dipoles, all like in a ball, just like this. And in the center of it is the dark matter. It forces it to the center. So you will never, ever, 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 ever see the dark matter. It's always in the center of all atoms. And we never look at bits and pieces of atoms except when you're in that particle collider or in ours, because we're looking at light. This is nothing more than pieces of atoms. When you smash atoms together and you get to this stuff here, you get a huge amount of bright. Everything's light. That's light. That's what we're working with, is light right here. When we smash it together, we break the black particle away from the white and we get pure white. And then we get just the black comes back to fit in with it. You see that? The black is completely, totally separate. You see, the black is completely, totally separate. It can't get through this tiny little slit, which is a venturi, which means it forces all the electrons to force their fields together, and they can't do anything about it. They have to, and when they do, the slamming black, bang, bang, forces and squirts, just like squirting a tube of toothpaste. And it squirts it right out of here, with a vengeance. With a vengeance. And you can see it does. You see the black? You see that black pushing the white? That's what it's doing here. At in the other shot, the black was smacking it before the venturi, and the only thing coming through was the white. This time we're getting letting a little bit of black through at the same time. The other one, as it was coming up to smash, boom, boom, boom. Not a single taste of white came through. I mean, black came through here. So the net effect of it is just like a big hammer coming, bang, 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 bang. And all of that white just goes flying through there. Now, if we could harvest it right there, with some kind of a little collector like that, because all we're doing is shooting a laser with the black and the white. The black stays this side, can't get through. The white comes through, we need to harvest it here. We need to get a hold of that white. All right, right there. It comes through, right there. That's this. The black stays on this side, can't get through. All we want is the white. And the white has no weight whatsoever. We run you make a plate in here, like this. And that plate is like a solar collector, only it's a little better because they have these new materials now, these thin film transition metal collectors. And this is going to be out of the, it's not going to be outside or, it's going to be inside this little box. And I'll show you, well, let me show you something. All right, I'm just envisioning this. It may work, it may not work. I don't know. But there is no question that an increase in luminosity is an increase in energy. We started with a very inexpensive source of energy, laser. It takes very little energy to power that laser. It comes out as a stream of light. It's light. Light is photons. Now, the fields are big. The particles are tiny, 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 tiny particle. Big, 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 big field. When that tiny, tiny, tiny particle comes down, it has to get through that tiny, tiny, tiny slot. The black can't get through. The black stays out. So we collect the white here. Now, coming down through that plate into a battery or whatever, because all it is the white. And it has no weight whatsoever to it, none, zero. And inside this box, you could have thousands, literally, of these little tiny lasers and receivers. They could be all over in here. And it doesn't take much power to run that. And of course it'd be watertight and all that stuff. And you just plug into anywhere you want. Turn any kind of voltage, amperage, any, cycles per second, any of that stuff. Anything you want. So this could be a universal energy source. And if it worked to increase the laser from the energy from here to here, and you had excess left over, you could continue the laser to run. You have excess. That's portable, free, clean energy. Only using light. We only ever started with light, so we don't ever break out. See what happened with them? Instead of using little bitty pieces like we use, they use these. When they smash theirs, something like that comes. Now, if that comes off of there and that hits you, that's going to hurt whatever it hits. It's going to destroy your cells and your brain cells and everything else, kill all kinds of things. We never get bigger than this. You're getting hit by this all day long. All day long. Light is everywhere. Everywhere. So this is not going to probably hurt you. I mean, you might, if you put your eyeball right on where it was accelerated, yes. You're not going to do that. That's going to be inside that box. You're never going to get hurt by that, and it's not going to swell up and increase in energy. It's just the same thing that you put in your battery. If you have an electric car, you fill it up. It never gains weight whatsoever. That's what this is a white. Now, if it works, we're in good shape. But I can't do this myself, and I have found very little interest by people I would have thought would be very interested. There's just no interest. So I just keep talking, and that's what I've been doing, talking. Now, it's going to require a change in the periodic table to some degree. Like hydrogen is not one big proton and one electron. It's about 1,825 or so dipoles. And this changes a lot of the way chemistry works. Now, I want to work with some water and start to talk about the intermolecular exchanges of how the water, H, works with the O. Because it no longer has like the same characteristics. There's not 6 electrons and 1 extra electron here, so this needs 8, so it needs 2 of these, so it's 2 hydrogens and 1 oxygen. It basically seems to work that way, but in my world, this is different. Hydrogen is not one big blob like that and one tiny little particle. It's this. Now, is it this and there's just enough electrons in there and it says, I don't want any more, but you can stay out there? But I won't let you come in here. We have enough, and none of these white guys will let you come into their region, so you have to stay out there. That's the quantum distance, maybe. Maybe that's what's going on. There's a lot to think about here, but I can tell you what, right now, the standard model's not right, so it's got to change. But a whole lot here doesn't have to change. It appears there's zones of stability, and they fit in here. But then there's all kinds of isotopes. And the isotopes are the same element, they call it, but it's all kinds of different sizes. You know, if you took phosphorus and you take all the isotopes of phosphorus, they go all the way up here, all the way down there. So phosphorus is way, way, way different in all of its different variations. And all of these are. Every one of them has a ton of different isotopes. Isotopes allow life to work. It always gets deeper and deeper and deeper as you go down. They talk about a rabbit hole. Well, this rabbit hole never stops. There is no end to it. Because you have to get down to be able to understand this right here, this particle. You have to understand the electron neutrino, big and energetic, or tiny and squirt through, and the black bowling ball muon, which is dark matter, never changes, never been seen. It doesn't emit energy, it doesn't radiate, it doesn't reflect. The only reason we can see it is because it's sitting on top of where white was. You want to see why we can see this? Where did you go? Where did you go? Here we go. You see the white here? The black is sitting right on top of it. That's how we can see them. And this one of them got picked out here as it was coming down the line. Is the one that Rod was showing right here. You see it? It's showing up because it's getting re-radiated backwards. That particle right there is what you would see if you could see the interaction between it hitting the wall and bouncing back. Because it thinks it just hit a wall right here. That's why we can see it. It's still in the air and perfectly formed. You could, I don't know if you would ever see that. I don't know if you would ever see this. Except for the fact that this is pushing back against it. Normally, you would see something like this when it hit the wall. You'd see a little blob or something. But here, it's in the midair. It's already expanded to its energetic value of interacting with a wall. It thinks it hit a wall right there. And I show you why I can say that. Because it's coming down here. And here it's just like very, very little energy. It's starting to accelerate because there's a Venturi. A Venturi forces particles to accelerate. So it starts to accelerate like a rocket ship. And it's because of the Venturi. And it's a fully understood principle. Now, there's a particle right there. And it's going as fast as it can go at this point, but it's gaining speed. It's getting more energetic, more energetic, more energetic. And right about here, it thinks it hit a wall because of the radiation backwards. And they all do. They all think they hit a wall. You never even saw that particle. That particle is here. This particle's back here, this particle's back here, this particle's back here. They're all there. You never see these particles in the air ever because they're not interacting enough with what's in front of them. To give you any sense, you might see a little glow, but that's about it. Here, you see in the particle, just like it's right in your face. And that's because it's smacking back against it, just like that had hit a wall, just like this had hit a wall. And that is why we can see the photon in its most magnificent form. Otherwise, you see these little glowy blobs. You don't really see, in other words, here you see this stuff here. You see kind of glowy, blobbyish looking things. But here is directly in line with the Venturi. And this, it thinks, is a wall. And it's actually literally bouncing back from that wall as a photon. Nobody's seen this before. Nobody's seen these. And the only reason you can see it is CMOS. CMOS is complementary metal oxide semiconductor silicates. And they are made to absorb these photon energies, and there's an amplifier in every pixel, so it works fine. And CERN is using CMOS now for their detectors as well. They just upgraded to actually use it because they need to use heavy duty stuff because they got these gigantic particles. We're down here. We're down in these particles. That's not going to damage the CMOS. They're hitting them with these gigantic chunks of particles. And that's why they had to radiation harden the whole system. So anyway, I'm going to leave it at that for today. But this is dark matter can separate. And in space, it can just float away from the white matter. And it depends on where it gets torn away. How much excess black is there compared to the white? In this case, they had a whole bunch of extra whites that they charged and put in with this, so we can see a really good distinct separation. I don't know what you see in space, how well they would form like this, whether they would push these particles together. Don't forget now, this is a containment vessel. This is a chamber. So there's going to be some kind of pressurization in there. I don't know what kind of pressurization there is in outer space, if there's any. They may not form black holes naturally, just naturally take those particles and push the black together. There has to be some source of excess black, and I think that's exactly what we have on Earth, because Earth is a ground. Every white particle there is, electricity wants to go into the ground. It wants to go into the ground. Electricity, lightning, static, right into the ground. So I say our Earth is literally is saturated with dark matter, black matter, and it will absorb any one of these electrons. And they want to get to the Earth desperately. So that's it for today. Thank you. I love you all. We got a lot to learn, and it's just I have a fun time doing this. I hope you enjoy it. All right, stick with me and pass it around. Get other people to pay interest, and the kids especially. Have the kids work with you, and talk to them about this stuff, because this is they need to be educated, and they are not going to get educated in a school system anymore. That's a done deal right now. If you've been watching me and you think that your kids are getting educated by going and getting the core curriculum, well, no, good for you. All right, I love you all. Goodbye.